Welcome to this workshop. It's the first workshop in a workshop series that OIT and libraries together are developing on the subject of data science and everything that comes with data science. This course is, or workshop is a first workshop, Introduction to R. The sign-up page, if you click on register here, or if you sign up on the library website, is a little confusing because this workshop meets 4 times and it has 4 sessions, but kind of the system lets you sign up for each time individually, and that makes it confusing because if you miss the first session, it's going to be kind of hard to catch up on the second session. So if you're signed up for the first session, didn't sign up for the second session, I think that's going to be fine. You're still going to have a place in this room. Did everybody know that it meets 4 times? If you didn't, and you didn't plan your life to spend so much time here, you can actually pick and choose, and you can come to session 1 and session 1 and 2 and see how much you get out of it, and then decide to keep on going. The things that we're going to cover here are session 1 is we will talk about what is R, how do we install R. You're lucky because here in this room, R is already installed on the computer, but if you want to use it somewhere else, you have to install it. And then some basics of R. So R is a programming environment. So we will talk about programming concepts. Who did already receive formal or informal programming education or programmed something before for school or for something? So we have some people who didn't. So it's going to be like a jump in the cold water, but we're going to do it. And then after we are done with some very basic things, and it ends up being how do I use math in R? Most of you, I guess, used Excel and you know how to add up numbers and do something to columns in Excel. So we will look at how to do those kinds of things in R. After we're done with this, we talk about even more in-depth programming concepts in the second session, where we talk about things like functions. And you can think of them like in Excel, where you write equals average and you give it some sort of column. That's a function. It gives the information to the function and gives you the answer, which is the average of the numbers. So we need to think about those concepts in R as well. And we will end up, hopefully, if we have enough time, with some basic visualization plotting functions in R. One of the really cool things about R is the capabilities of making really cool plots, giving lots of data. Then in section 3, we'll talk lots about data handling. I think if you use Excel and you use some data that you were not typing in yourself, you know that you can download CSV files or Excel files and open them, right? Or maybe somebody emails your Excel files, and the question is, how do we get those files into R? How can we kind of clean them and use them in R? And the last part is section 4, which is then data science in R. And that's going to be more advanced, where we actually already know how to use the basics of R. We know how to handle data, and now we're going to use data to make, for example, decisions. And we will look at how do models in R to make decisions, how do they look like? Usually they're called predictive models, and they have a very similar structure of I have to have some data, I need to learn some sort of decision rule from the data, and then I need to apply it to some new data to make some sort of decision. Sounds a little confusing. If that's confusing, not a problem. We're going to talk about this here in session 4. And then we are done with this workshop. After this workshop, there is going to be a second workshop on the topic of R, and it's going to start probably a week after this workshop ends, and that has a focus on text mining with R. And then depending on what you guys all need, and I will ask you kind of towards the end today of the session, what the things are that you really want to get out of this workshop, we will then plan to do either individual sessions with some of you to like teach you really quickly the things that you need to know, or plan workshops like this, maybe that we meet only once, so short workshops on a very specific topic, depending if there is enough support. Our plan is to offer those workshops on a somewhat regular basis, every semester, every year, and so forth, to give you this kind of option. Okay, first thing, maybe this website for the workshop. It's kind of tiny to read. My name is Michael Hassler, so if you type in the computer michael.hassler, and that's already tricky, maybe I can make this bigger in some way. I'm not a Windows user, so I'm kind of lost in this environment. I push buttons and something really strange happens, but I will get through it. I know, but the word is just so slow. It took so long to load. So let's make a blank document. And to make the browser bigger, yes, but it doesn't make the title line bigger. Like if I do that, so I will paste it in here, hopefully, and then I can make it big. Okay. So this is the link to the workshop homepage. It's michaels.hassler.net. There's a secret H in there after the A, and then /SMU/DS, and those are underscores. They're just like underneath this line. So DS_workshop_intro_R, and then you should get to this web page. I will ask them to give me a list of all the people that are signed up, an email list, and then send you the link later on, probably tomorrow when they give me the email. But here for the class right now, this should work. That everybody finds this web page? Yeah. Okay. Then let's move on here. And I can make this bigger here, but you see the URL doesn't get bigger, so that didn't help me really too much. Okay. There is a short introduction, and the same introduction is found on the page where you signed up at the library of this course, and it tells you that we will use R to kind of make certain processes that we want to do with our data more repeatable. And repeatable means in Excel, you would have to push like always 5 buttons. You get a new data set, you push the same 5 buttons. Often you feel like if it was only 5 buttons, but actually it takes me half an hour every time I do this because I have to copy things around. And with R or programming languages, we can do this hopefully in a more automatic manner, where somebody gives me the new data and I just like start the script and it's going to do all those things and spits out the result. And I don't have problems like, oh, I forgot to push this button after that button. Now I have to go back and redo all those things. Okay, that's really where we want to end up with this workshop, that you're able to do things like that. Here, for each session, I have a slide set, and this one is the slide for introduction, and then I have some sort of like material stuff down here, and this is what I want to look at first, because when you get home or to your office or use your laptop, you have to install the environment. You have to install R in order to use it, and RStudio, which is the development environment that we're going to use for R. And there are links here. You just click on the link. This gets you to the R programming for statistical computing project, and then there's a link to the left here. It's called download. It's called CRAN. Then there's lots of confusing choices. Just use zero cloud. It just means that this project has copies of itself everywhere on the internet, and you choose the one that's closest to you. And then here you have the download buttons. Download R for Linux. That's not what you probably want. You probably want to download R for Windows. You go there, download it. It will probably warn you and say, hey, you install something. Do you really want to do this? You say yes, and then you install R. R is important because RStudio doesn't really have this programming software in it. It's just a user interface. It's kind of like if you're programming something, then you might have a compiler and a text editor. You write your program with your text editor, and then you use the compiler. So R is kind of like the compiler for this whole thing. Here, R should hopefully be already installed. The second thing that we need is RStudio, and that's the link down here. And we need to install it. And this is kind of tricky. They change their website sometimes. So under products, there's RStudio. And then here, I guess there's RStudio Desktop. And it gets you here. And there's several editions. The edition that we use is the open source edition, which is the free edition. That doesn't cost anything. They're always scary. It's about $1,000 a year for one person. So we installed this free edition. They basically can do the same things. The Pro edition comes with desktop support and all kinds of things. We don't really need those. So you install this here, download, install. And once you're done, you should find somewhere a button like this little circle with an R, and that's RStudio, and you will be able to start RStudio. Hopefully. Maybe I have to double click it on Windows. We'll see. Or it just is really slow.
What was the first download?
The first download is R, and that's the programming language itself, and then RStudio is the environment. Here, both of those things should be installed for the latest version. Maybe something about that. It's open source software, which means that they have a new version every like 3 to 6 months. And sometimes things don't work, and the reason is because you don't have the current version. And what it just means is you need to go back there and install the newest version. Sometimes it even complains and tells you have an old version. You just have to update this here. Okay, so
Looks like it's already installed on these computers.
yes, I asked them last week to install it because
It says R there, so,
yes.
so here we go.
I think what I had to do here is I had to go to this thing here and type R, and then it would offer here that there is something installed with that starts with R, which is RStudio. Okay, and once it starts, it looks like this. This box to the left here is really how R looks like. It's just like a text box where you can put in commands. That's not very user-friendly. And all the other things that we're going to use in the class, all those other windows, are actually there to help us and make the experience interacting with R and writing programs in R a little more pleasant or less scary. Okay, so we'll use this in just a little bit. Let's go back to our slides where I have them open here. And let's start with the introduction. So I taught a workshop like this before, and what I did is I just opened RStudio and started typing like crazy code. And that didn't go so well because people were really, really confused. So what I did is I actually made a slide set that has regular slides with more or less text on it. And if you want to execute the things that are on the slide set, you can actually copy and paste them into R and execute them and see what the result is. And those slides you will see, they actually have R code and the results that we expect from RStudio in those slides. So let's open the first slide set. I think I downloaded the slide set somewhere as well in order to open it in full screen here. So let's get rid of this and I put it here. It's not the fastest. And then I do something like this, I think, hopefully. And then it shows the whole slide. Okay, so this is part one, the introduction to this workshop. And let's start here. What I want to cover is, first of all, what is R? I told you just now how to install it, but what is it really doing? And why do we need it? And then we will do some very first session with R. So we will start R and look at kind of the environment, look at what we have there. And then we go through R basics. And after you're done with the R basics, you actually can do some very simple calculations with R, like calculating the average of something, similar what you can do already in Excel. Just you're going to do this with this environment. And then we're going to build on this. I have some exercises too that we're going to do either here during the workshop or you can do it to them at home. They're going to help you kind of like train the things that we do here in this workshop. Okay, what is R? R is an environment that was developed for statistical computing. And that sounds kind of meh, right? It has the word statistics in there, computing, fine, but it doesn't sound very exciting. But actually what R developed into is a big, broader software where you can make write code for lots of different applications with a strong emphasis on statistical things, but also on data handling, data management, visualization, and predictive modeling. All those things that are cool, machine learning and so forth, you can do those in R. There's other environments like Python that can do this as well, but R is one of those. R is completely open source and it's governed by the R Foundation, which is a non-profit organization that decides on what happens to this programming environment, and that takes care of things like storing and making sure that all those extension packages work. So they do lots of work for us. They do it for free. They get sponsored by SAS, SPSS, Microsoft, IBM, all there, but they don't make any money. This is a pure open source foundation, comes from academia. Most of the resources come from universities. That's where this comes from. There's lots of work done on statistics and graphics. For statisticians, the R programming language is the de facto language that they use to explain algorithms, which is kind of like a a strong thing. They literally speak a programming language. All those statisticians are not programmers, right? They're statisticians. But that's a very interesting thing, and lots of statisticians decide to write their new things in R and give it this way to other people so they can do their new things as well. And it implements lots of things that we want to do. For example, all kinds of predictive things, linear regression, which some of us need to do, predict some things. They're all implemented in the system. What does R give us now? It gives us a way to handle and store data. Similar what Excel does, right? It gives us a way to like organize our numbers in a table and store them. It gives us support for all kinds of operations and calculations that we want to do. And we'll see how those work in just a little bit. It has a really ginormous integrated collection of different tools of things that we want to do with our data, like cleaning, visualization, and they all work together and they make analyzing the data very powerful. But you know, with power comes difficulty. If something is very powerful, it gets to be complex and not as easily usable as a thing that has only one button that says push me. It does lots with graphics again. It has a very effective programming language, and some people call R a programming language, but it's really this whole environment. And it has an extension mechanism which is kind of unique because those extension things are not done by a company. Like you can buy extensions to your browser from Microsoft or whatever it is, or extensions to Word from some companies. They all come from contributions that are open source from people. And just keeping all those extensions working together is a major effort. And R provides methods to do this, and that makes it very powerful and very community driven. So why do we want to use it? R is open source and free. That's yay, right? We don't have to pay lots of money unless we want to give our studio $1,000 a year, but we don't have to. There's an open source version for that as well. It is completely community driven. No company owns anything from R. There's companies that provide support professionally, but it doesn't mean that they own R. Microsoft, for example, provides professional support for R, but it doesn't mean that they can decide anything what R is supposed to be doing and how it's supposed to be doing. Those extension packages I checked last night, there's 15,000 extension packages available currently for R, and they range from very small things that do something very specific, like a certain type of visualization, to more broader frameworks where you can work with large databases and things like that. It interfaces really easily to lots of things that other people want to use. So programmers like to program stuff in C++, R interfaces to C++ code. It interfaces with Python, it interfaces with all this Google Big Data, Apache type things. So it can talk to all those things very easily, and that makes it very useful. R makes not just great visualizations, it makes beautiful visualizations. And a while ago, the New York Times and The Economist used R as their main engine to actually make all those charts that you see in their online newspapers. And the good thing is you can download the template for The Economist and can make your own charts look like they come from The Economist, which is great because they look awesome. Which is scary because I can put them online on Twitter and say, oh, The Economist just said this and that. And I totally made up the numbers. But that's, you know, that's what it is. And RStudio, which is a company though, they make reporting and creating dashboards and creating interactive features and creating websites that present data really, really easy. It usually is, if I can make a plot in R, I can add 2 lines and all of a sudden it's a widget that's on the internet, or it's a widget that's in an interactive report with pull-down menus and all kinds of things. Okay, let's move on. Now the issue, all those awesome things that I told you about, what is now the big issue? Well, the big issue is the learning curve. This is on the y-axis what you can do with it, and this is the learning effort, and you see, you learn, and you can do anything. And it's super frustrating. At some point, it starts to dip, and you learn just a little more, and all of a sudden, you can do things really, really quickly, really efficiently. Whatever you did like in a week before, you can do in half an hour. And what took you a week before to do it every time, now you can like just push the button after this half an hour, and it does it like instantaneously. So this is very powerful. The unfortunate part is this frustration at the beginning, this learning curve. Did anybody try to learn R by themselves before? How did that go? It was very depressing, probably, right? And the question is, why is that? Obviously, R can do all those awesome things, right? So it's very complicated, but does it have to be so complicated? Could not Apple make an R version that is like easy like an iPhone and you just like do something and it does it? And the answer is, well, the reason why it's so complicated and confusing is because it uses concepts that are not familiar to normal people who even do a computer science degree and learn programming, because R is mostly a functional programming language. And functional programming languages are very different from the programming that we learn in class here. We learn usually imperative procedural languages like Java or C++, where it says, I say this variable gets this value, there's a loop and whatever it is. R works differently. That makes it confusing to look at the code and understand what the code does. I didn't put here one other thing. R is vectorized, a vectorized programming language. What is that? Well, it's going to be something very confusing because most of the operations, when we do them, are actually matrix multiplications, matrix divisions, adding something to vectors, and we are not used to live in that world, right? Although if you use Excel, you live in this world somewhat, because if you make a table in Excel, like use the table function, and you want to add one to a column, it auto fills out the rest of the column nowadays, which is really awesome. There's this like little lightning bolt thingy that does automatic stuff for you. And what it really does, it vectorizes this operation, says, oh, you probably want to do it to every row in this table. Okay, makes it all very confusing to look at things because some people are tricky and they say, I could write it easily. I can also mathematify it and write it in like some matrix notation and nobody can understand it, right? And they do this to protect themselves because then they're still needed, right? Because they know how to do it and it's so easy and other people have a hard time. So that's just the thesis here. And the other thing that makes it so difficult happened actually in the last 5 to 10 years, which is R evolved from what we call base R, which is the basic functionality of R that we're going to talk about here in this course, into something way wider. So they added things like tidyverse, which makes handling data super easy, but it uses very different concepts and very different syntax. They added for plotting ggplot, which makes really nice visualizations, but it's more complicated. And now what you see is when you try to find a solution, all of us Google and say, how do I do this in R? And when I learn R, that's probably what I do. I see from different places, different solutions that come from complete different angles. And I get completely confused because I see here, oh, this is how you do it. You say plot, blah, blah, blah. And then all of a sudden they say, no, you have to say plot plus. And I try to put the plus over here and it doesn't work anymore. The whole thing breaks. So I take 2 pieces of code, put them together, and it's chaos. And I cannot learn one of the concepts because I see always a mixture of concepts. And that makes it very, very confusing, right? So point of this workshop is we're going to take the concepts apart and talk about one concept so we can understand it in depth. And then later on, we can go ahead and say, oh, I know I can do this easier, but I need to switch to a different way of thinking. And I need to learn this different way of thinking. Okay, so far so good. First session. So we open up, let me go back to R here. We open our studio. Let's make it big. And I think I can make this bigger as well here. And we need to look at what we have here in different places. Here, this is called the console, and you see it's highlighted here. Console, there's other things like terminal and jobs. We don't really need them here. And this is where we really type R code. So I can type something in here. I can, for example, type here 1 and push enter. And then R executes whatever it's supposed to do when it says 1. And you see it answers something here. Not very exciting because it says 1 in brackets and another 1. And that's how we can interact with R. I will show you in just a little bit that that's not the preferred way to do it, but this is where the R code goes. And then we have different other windows here. It says global environment, some history. It says the history is I typed 1, so it remembers the history. If we load data from a database, there's connections. We don't need those right as well as here. And down here, it can have plots. We can look at different packages that are installed. We can look at help. That's important. We're going to use this in just a little bit. And then a viewer for some more interactive interactive usage. Let's now go back to, I hope I didn't delete my slides or close my slides. No, there they are. Let's now go back to the slides. It doesn't come out on the screen here, but there is slight gray boxes behind something. And when there's a gray box, then it's actually code that you can take and copy into RStudio. And if it's white and has those two number signs in front, then it means this is the output that R will give you. The way that I created the slides is I wrote this code, gave it to R, and R executed it and actually put the results everywhere in here. That's called Markdown. It's very nifty because you can write a report, can put code in there and say, and now translate this report, and it will fill it out with figures, plots, and other things. And we will talk about this when we talk about data science with R. So the first thing here, let's see, hopefully I can do this, is if I copy this thing here and I insert this into my RStudio with just copy and paste. Well, it ate the line. Then we see it says the same thing, hopefully, what it said on the slide. It said here 1, 2, 3, 4, 5, 6, 7, all the way to 10. Let's not take apart what this syntactically means. X is a variable name. Well, it's a functional programming language, so technically there's actually no variables, but it's a name. And this arrow to the left, which is like a less than sign and a minus, is the assignment operator. And then on the right-hand side, we have here 1 colon 10. And that's just the magic way how R says, I want to go from 1 to 10. I want to count from 1 to 10. And instead of ... it uses the colon because it only needs one character. And when they developed S, that's what they decided on. So what we do is 1 to 10 is a sequence of numbers. And I assign them the name X. That's really what it is. And later on, when I look at X, I will get the values that I assigned here. And this is what it said. If I just see X, then R says, oh, you probably want to know what X is. And it tells me here what the values are. The first thing in brackets is actually a line number. It tells you the index of the first element of the line. This is only one line, so the index of the first element is 1. In R, indices always start with 1. If you had a programming language where it started with 0, you have to rethink how things are. In R, it starts with 1. So that's pretty good. So we have this X stored. Now we can do operations. For example, we could take X and add 1 to it. And then assign this to the name Y, and then we can look at what Y is. And we see here Y is the value 2, 3, 4, 5, 6, 7, all the way to 11. So it took each element of X and added 1 to it. So it's very similar to when you take Excel and have a column and you want to add 1 to it. Probably you want to do something more exciting than adding 1 in Excel. But that's just what it does. And this is a very important concept because in R, everything is a vector. Everything is a sequence of numbers or names or whatever it is. And whenever you do an operation, it will do it vectorized, which means it will apply this operation to each element. Which is good because we can now do actually 10 additions in just one go by just saying take the vector X and add 2 plus 1 to each element of this vector X. Okay. How does R store that there is a name X and a name Y that we use? And how can we figure out what the values are? And the answer is there's a function called ls, or listing objects. And in R, lots of things have brackets or empty brackets. And the reason is it's a functional programming language. And if you had a programming language before, then brackets usually mean that you're calling a function. And in brackets, you put whatever the arguments are. If you think again about Excel and say, equals average, and then in parentheses you have, I don't know, column A from row 1 to 20. That's the argument. That's a function call. That's the same thing here. This function is just poor. It doesn't get any information. It just gets called. And then it tells us, we right now have the objects X and Y stored. And we'll talk about objects a lot next time. Mm-hmm.
So what's the square brackets?
This one. This is just an index for the line number. So every line, I will later on have a slide where there's like output that spans several lines. This is the index of the first element. So for example, if I had like 100 numbers, it might say here bracket 10, and this is the 10th value all the way to 19, and then it would say bracket 20. It's kind of just telling us if we have a long output, like where in this output are we? Because they figured out that practical applications require vectors that are usually longer than you can like just write in one line. So this is not, the data really starts after the bracket. So this is the first element. Okay, and you will get used to it, and you will see this in lots of other things. If you want to quit R, yes.
Just a quick question. So we define some variable, crazy, or X and Y. And then now, how does the system remember what X and Y are? When that seems to me like that's the console. We haven't actually typed anything.
So if you take this and type it into the console, then you will see that R knows what you typed in the console and remembers it. That's what we're going to do right next here. So let me make this small again. And let me retype this here. So we already have X, right? So I typed in X, right? And when I say X, it says 1 to 10, the same thing that we have on the slide. And then what did we say? We say Y gets, and that's how they call the assignment operator, X plus 1, right? So I just type exactly the same thing on the slide. And I say Y, and now it says this is 2, 3, 4, 5, 6, and 7. And if I say LS, then it says right now the things that you gave a name is X and Y, and I know I still store them. And whenever you say X, I can tell you what X is because I store it internally, and I can tell you what Y is. Since this is kind of painful, it has under environment actually a list of everything that's currently in there. So if I want to make something, for example, I want to say Michael, and Michael obviously is a 10, so I give Michael 10. Then we see Michael starts to pop up here, and it says Michael is 10. Okay, so far so good. And this is called the workspace of R. The alternative name for this is the global environment, and we see that it says here, this is the global environment of R, and that's where all the things that we use are stored. Which is great because we can look up what we have here. If it's more complicated, we can actually click it, and it will let you inspect what the information is in there. And let's now go further with what we can do with this. So we can use Q to quit. This is not really necessary in R Studio because in R Studio you can go to File and quit, and then you also get out of there very easily. Okay, how do we now get help about things? So how did I figure out that LS shows me that there's X and Y in there? And the help facilities in R are a question mark, and then you type the comment that you want to have help for. So you could say question mark LS. This is actually only sugar. It's called syntactical sugar of R, but really what you write is I want to call the function help and then put ls as the argument. Since this is so much typing and nobody likes it, they actually make a short form like this, but really what it does is that. And if you do two question marks, then it searches all the help that R has built in for a given keyword. So let's try those two things really quickly. And I go through those so slowly because this is really important. Because if you don't know how to find help, it's not going to be good. So if I say question mark ls, then I see down here it changes and it goes to the documentation page. And it says here, I'm doing documentation for ls. This is part of base R. This is for listing objects. It has a description. That's really great. What it does. It has a usage and it says you can call ls with different arguments. We called it with nothing in there. It has for each of the arguments a description of what they mean. Has some more details, and the really most important part, it has all of them have an example section where you find code and you can copy and paste code over there and see what it does. Most of the things that I learned about using different functions was actually I mostly skipped the part here, looked at the examples and say, can I use this for what I want to do? And I find the example that's the closest to what I want to do. And then I copy and paste that example. Since help is here, you can actually also, instead of going down there, you could actually just type things here and it will go to the help page of ls or the help page of, let's do plus. And then it says, oh, this is not good because it gives it quotation marks. Let's just try plus. It was too smart. And then it says, yes, this is arithmetic and the usage is plus a variable plus another variable and so forth. So you can look for help online in this kind of help. It also has hyperlinks. So if it says, oh, you should look at this other function, you can click on it. It goes there. It's very, very convenient. And you see, they were not slouches when they did their documentation. They documented things really, really, really well. Okay. So this is how to find help directly in R. The only downside is, in order to find this help, you kind of need to know how this function is called, right? If I have no idea it's called ls, I'm not going to find this manual page. So the options that you have is, you can go to Stack Overflow and just like type in and say, I want to do this and that with your own words, or with some words that you use for your application. You know, that's what people usually use. And they will actually give you some sample code, and you see what functions did they use, and then you just like do help for those functions, and you will figure out what's going on. And that's how you learn Python or any programming languages nowadays. So Stack Overflow is very good. You can also just Google it. Usually you will get a Stack Overflow function where another person asks pretty much exactly the same question, and then some nice smart person said, oh, why don't you do it like this? And they often give you code, and you can copy and paste it and use it. A little more structured, if you need help, there is in the manual section on this link here, and that's the same link where we downloaded R, a document called an introduction to R. And what we really do right now in this workshop is we go through the first 12 chapters of this documentation, and it's very basic of how do I do different things. So that's a good place to learn the basic functions that you have in R. Then, if you want to find actually a package that does something very complicated, there's something called task views. And I'm going to look really quickly at those, where you can kind of figure out, this is the problem that I want to solve. Where do I find functions that can do something with that? And this works like the following. Let's go here to the browser here, plus, and I will go to Grand. And to the left side here, there is manuals. And this is where you find an introduction to R in all popular formats that you want to have. So you should read this. And then here it says task views. And task views has sorted by whatever your application area is. No, this doesn't go bigger. I have to probably click it, or I have to do this, I have to do that. For example, here, for clinical trials, if you're interested in clinical trials, there is a task view here about clinical trials, and you click on the link, and then there is some editors that basically describe what does R do for clinical trials, and then they have a list of things, and in this place, they support you with code that does this, or functions that do this. And you see this; those are pretty long lists, and they say package DFPED, whatever that means, is a unified method for designing some things. If you go back here, you will see there's lots of them. For example, if you work in finance, you go to the finance task view, and then there's a different other editor, and then it says there's all kinds of different packages that can help you analyze stock markets and whatever it is what you want to do. You would never be able to find those packages if there were not somebody basically guiding you and telling you, oh, you know, this package does this package does something else. Of course, you can go the way of Googling it, finding Stack Overflow, and then somebody used the package and you kind of like learn it that way. But this is typically easier because they kind of describe also the differences between if there's two packages that do kind of similar things, what are the differences, and you can make your own decision which one you want to use. So that's the task view. That's pretty important. Packages have also description in addition to those manual pages. So whenever you install a package, you get the same type of manual pages that what we looked at right now, where we looked at, for example, this page here for the plus operator. And those documents are usually written more like a report, like an article that explains to you why do people do it this way and gives you examples. And those are called vignettes. And I will show you where to find those. Those are those vignettes here. Let's go back to the comprehensive R archive. So under software here, there's R binaries. That's where we can download things, and there's packages. And under packages, let's just pick one. So there's a table here. Let's take this one. All estimates. I hope this one has a vignette so we can look at it. It does. Then for this package, there is, from the person that wrote all this code in this package, a description about what the package does, what other packages it needs to use. And down here is manual pages. And if you look at manual pages, it has just a PDF document compiled of exactly those manual pages that you can also see in RStudio down here, just as a nice document. So you can print it, mark it up with highlighter, and look at it. It's organized exactly the same way with examples here at the end. And here under vignettes, and I hope this package has a good one. This one has a web-based vignette. So it's a document that basically explains to you, usually in terms of a use case of how do I use this package and how do I get started, how do I use it in an example and so forth, and with some plots. Let's maybe find one that has a vignette that's a little bigger here. Oops, let's go back to this page. I don't know which one to take. Let's take Fuzzy Forest. Maybe that one has a vignette. No, it doesn't even have one. Let's go back. Oh, this is slow.
Yeah, I think the all estimates has one.
Mm-hmm. Yeah. Oh, this is interesting. My search doesn't do what I wanted to do. Which one did you find?
So the all estimates that you were showing earlier.
Yeah, it has one, but there's other ones. There's PDF files that are like really like reports or papers.
Okay.
Okay, so far so good. So this is. Mm-hmm.
So to learn R, is it necessary to remember the codes or something?
When you remember the codes, but what do you mean with remember the codes?
Like syntax or something.
And so in order to really learn R, you need to remember the things that I will talk here about, like how to add certain things, how to call a function, and so forth. So that is necessary because in the end, it is a programming language where you have to write this code, or at least be able to copy the code from somewhere else and then understand what it does and edit it so it does the things that you want. But in order to be able to fix it and edit it, you have to understand what it does, right? Mm-hmm. Yes. Yes. So the good thing is R manages this for you. You don't have to really worry about it. You just go to tools, install packages, and you just like type in the name of the package, say install, and it's gonna know where to store it. It's gonna know what to do with it. So that is the good part. All you push is the install button here, and we will do this later in this course. Okay, let's move on here. So this is how you get help for packages and R functions in general. So now about the R language itself. So you need to learn some basic syntax in order to be able to like fix code. And R is a functional programming language which makes syntax a little awkward for some people, but it says here mostly because actually for reasons of making it more accessible and useful for certain things, actually it breaks the functional paradigm and you can program as if you were programming Python if that's what you desire, but that's not really what the language is made for, and sometimes you end up getting code that doesn't really work well and needs to be reworked. So it is a language like this, but you will see that for us as users, it doesn't really make much of a difference. Expressions, everything you type in there is evaluated. For example, if I have an addition, evaluation means just calculate the number that you get. And then the result is assigned with this left arrow. Be careful, don't use the equal sign for assignment. Lots of other programming languages use the equal sign. Don't do this in R because there is a difference between an assignment with an equal sign and with this arrow. You should use the arrow because in some cases the equal sign works. In other cases it makes very weird behavior and finding the error will be painful because it's going to give you some weird error message and you're going to be just frustrated. So don't do that. Use those arrows to the left, the less and minus symbol.
So it's the reason for the arrow because we're using vectors here.
No, it's just a convention that this is the assignment, and this is actually just an assignment that's used only in the global environment, has historic reasons from S why that's the case, and it's just, don't worry about it, just like write those like left arrows and you will be good.
I guess just remember these left arrow, right?
Yes.
Okay.
I think RStudio might even have something built in where you can turn on whenever I type an equal sign, it will replace it with a less arrow, kind of what Word does for you if you mistype some common mistyping things. Okay. Important thing is also R is completely case sensitive. Uppercase, lowercase, completely different in variable names, in everything. Keep that in mind when you work with things. R uses the idea of a line break after each command. You can also use semicolon. Don't do it. Mostly that's not necessary. Just like each line is a command, and you will be good. We will later on use brackets to block some things. And if you had programming language before, you probably use this for loops and all kinds of stuff. And comments start with the number sign at the beginning. Comments, super important because you're going to write some code for your work. And then a month later, you want to fix it and you want to know what you did. And you look at the code and you're going to be like, oh my God, why did I do this? This is really weird. If you write something that you think is even slightly weird, put a comment there and say, I did this because A and B. So that you don't break it later on when you think about it or can't fix what you did before. Next important thing is R has the concept of a working directory. And for Windows users, that's kind of like somewhat like confusing almost, because I think in the good old days, you had a home directory in Windows. Now you have like a documents folder and a folder for downloads and a folder for your desktop and so forth. R really starts up in one folder and it works in that folder. So it expects to read all the files from that folder. And whenever I write something or write down like some figure as a PDF or whatever, it's going to write it in this working directory. And you can check what the working directory is with the function getWD or change it with setWD. And since that is really, really kind of like not fun to do, RStudio makes it easier for us. And you go up here to session. And it says here set working directory. And you have several options here. You can go to, for example, to the source file location. We're going to use this a lot. Or you can just do choose directory and it opens this thing here and I can see, you know, I want to work on the desktop. Probably not a good idea. Probably you want to make a folder on the desktop and then work in that folder, right? And whenever I say open, then you will see it actually writes the code for me down here. It says actually setWD is on my C drive user, wherever my desktop is. Okay, this is though not the preferred way to do it, and I highly encourage you to do it the way that this recommendation here says. If you start a new project, for example, for the homework for this workshop, first step, create a new R script file. And I will show you how to do this. Then once you create this R script file, go to the folder or create a folder where you want to store this and store this R script file in that folder. And then once you have this, all you need to do is go to set working directory to source file location, and source file means this R script file, and will automatically go to the same folder, and everything will be stored in this one folder, and you can have a folder for your different projects. You can keep them apart because if each folder has a different project, you will never kind of like be confused and say, is this script that I called R script, the R script for this project or the R script for the other one? It's going to be organized. So this is what I suggest for you to do, and never write R code directly in the console, but write it in your R script and then execute it from there. And this is really easy and very good to do. And let me try this here as an example. So the first thing that you should do is you should say new file, and here R script. And you see R actually can make all kinds of things. It can make notebooks and so forth, but we want for an R script. It has here this untitled R script that opens up here. The next thing is I say save it as. And if I really want it on my desktop and I want a new folder for it, then can I create a new folder here, a new folder? And I call it R workshop. This is where I want to work in. Then I open it, and then I need to give this file a name. I call it my first script. And I say save. And now it says out here on top, it's my first script. It knows that's an R script because that's what I created. So it gives it the extension .r. And now I can write here, for example, x gets, what did we have? 1 through 10. And whenever I click save, it's going to save it to the script file. So it's going to be saved. I'm not going to lose it anywhere. If I want to execute it, there is this run button here. And whenever I'm in a line and click run, it's going to copy it down there and execute it. Or I can even easier, like go to a line, hold control and push enter. That's the same thing. And what I usually do is I write all my code in one script, go to the place, the beginning of the script, hold control and just like start hitting enter like crazy. And it's going to execute each line. You're going to see what the result is. And that makes things for me very repeatable. And very easy because all I need to remember is hold control and push enter. If I want to fix it, it's easier. Go to this file, fix whatever line I think is broken, go to the beginning and just control enter and execute everything over again. It's kind of like in Excel, if you have had the ability to do the same like 100 steps over and over again, change one of the steps, do them over and over again. And that's actually very powerful. That makes it very, very useful. And also all my things are in this my script. If I go now to my desktop, if I can, here, desktop, and go to my workshop, then I see there is this R script in there. If I now want to shut down R and start again, all I need to do is double click on this R script and R actually opens this R script, goes to the correct directory, hopefully in Windows, and you can keep on working on this. Okay, so far so good. Let's now move on to the next thing. So we talked about already that if I create some names that R remembers them, and we know that ls can be used to look at them, and we can look at the environment in our studio to look at them. Sometimes you want to get rid of those. There's a function called rm to get rid of them. It's not too exciting. I think in my whole career, there were like maybe 2 occasions where I really had to like remove an object from the workspace. So don't even worry. RStudio probably can do it by right-clicking it and saying remove. So don't worry too much. But what I want to get to is that this workspace and global environment is actually permanent. So if you start R, you create names and data and stop R, it asks you, do you want to save your workspace? If you say yes, it's going to save it to disk. And the next time you open R, you're in exactly the same place. You will still have an X and a Y exactly like you left it. It's kind of like closing your office door and coming back, and the desk still has the same stuff on the desk as last time, which sounds really, really great, right? But if you look at my desk at my office, that's not great. I would rather start with a clean desk every morning and not have that, and rather have like some folders where I know where things are. So my suggestion and recommendation is don't ever save the workspace, but actually write this script up there, and whenever you want to execute a script or the code, then rerun the script. R is fast enough to do this kind of thing. And there is a button here, source. And what it does is it goes through the whole script and executes the whole script. So unless this takes like 100 years, it's way better to start with a clean version of R and just execute all the commands here. It would be like you can start with an empty Excel sheet and have a button that says, do all the 20 things that I want to do to you. Make sure that it's clean and consistently the same thing next time. If you decided to save your workspace, other bad things can happen, which is, for example, you start R and it takes like 20 seconds till R starts. And you're like, oh, this computer is so slow, it's broken, right? But what really happens is it stores your workspace to disk, and if you put something really large into your workspace, let's say some image or something, or some large data set, it's going to have to read it every time you start R, and that slows it down, and you don't want this. And lots of people don't know how to fix it, and the simple answer is there's a hidden file called .rdata in your working directory, and if you delete this file, then the workspace is gone. It's literally just stores all the information into this one file. So if R gets slow, look into your working directory. Is there this hidden file? I think on Windows it's not even hidden. It's called .rdata, and if it's there, you can delete it if there's nothing in your workspace that you need. If you follow the recommendations here, there should be nothing in there that you need because you have the script and you can run it and it's going to do everything for you anyway. So this is the recommendation there. Mm-hmm.
So, I'm confused with what is .rdata versus R script.
So this is an R file. Let's let's try it. I hope we can do this. So I have now in my R environment, I have the name Michael, X and Y. And if I gonna quit, then it says here, save workspace image. And if I say save, then when I start my R again, it saves it here as my R data. Let's go, how do I start R again? I guess I have to click this. Then hopefully it loads the workspace again, but potentially I messed it up. I think I did mess it up. It has this file still open, but it saved this file here, this .r data file. And on Windows, I guess it doesn't open this R data file again. I use it on Linux and things are different. But if you double click it, it opens again this workspace. And if you don't want this, you can just like take this and like just delete it, and that's gone. And sometimes Windows or R Studio will be really slow coming up, and it's because this file became so large and so huge. It's kind of like my desk after a month, and I didn't clean anything up. There's like just too much stuff. I don't even know what's on my desk. Okay.
So after deleting this, our program is done.
Yes, so I can start RStudio again, but now it's empty here, right? Because I deleted whatever was there, and that's empty. So unless, if I have all the code that I need anyway here, I can just rerun this and I will get the same thing again. Okay. Should make life for you, hopefully, a lot easier. Now we can start with our basics, and now it gets to be tricky and hard, because now we really start with like programming stuff. So the first thing is, I could just type 42, and then R answers to me and says, you know, I print the values that you just gave me here as a line. It's only one value, it's only one line, so you have this one here in brackets, but it's really the value 42. Seems like it's a so-called scalar value, it's just one value. But the truth is, R doesn't understand what a scalar is. R only understands vectors. Everything is a vector. It's a sequence of numbers. It just happens in this case to be a sequence of only one value. There's also sequences of 0 values, then it's kind of like it prints an empty thing and says, yes, it's a vector, but there's no value in there. So you need to get familiar with the idea that everything is a vector. If you again use Excel, everything is a column, right? And there's values in each row, so it's not such a weird concept that everything you care about, all the information is actually not just one value, it's several values, and each value could be for a different person or whatever you want to deal with. Okay, you can take individual values and combine them together, and there's a function C, and they use C because it's used so often, and you only need one letter, so that's why they like C. And it just takes values and puts them together into a vector. So, for example, 10.4 all the way to 21.7, and it creates this kind of vector. In math, you would probably just write it in some vector notation or whatever it is. Or in Excel, you would write it in one column, one value below the other. Okay, and then we can do element by strings. I think we did x minus 1, right? We can also say 1 over x, and it will just take each value and give you the result of 1 over x. We don't assign it to a name, so we just see the results and they're gone. They're not stored in the workspace anymore. You can use also combination to take a vector that you already have and combine it with new values and take another copy of this vector. So it will take the vector with x, those values, add the zeros at the end, and take those values again, and you will get this long vector, and now it's longer than a row. You see there's 2 fields with brackets. The first row starts with index 1, the second row starts with index 10, because there's the first, second, all the way to the 9th number, and this is the 10th number, 11, 12, 13, and so way to the end. As you see, it took the values for x, it added the values 0 that we had here, and it took the values for x again and copied them together. Here's a contrived example. Don't worry about like the meaning of why you would use this. Later on, you will see that it makes sense to copy vectors after each other for lots of applications that you want to do. And you do this probably in Excel all the time because you copy a part in Excel and paste it somewhere else down there. And that's really exactly what this thing does as well. Okay, vector arithmetic. What can we do with vectors? Well, we can take now this vector x that we made and the vector y that we did and can add it together, x and y, and then we get something that's kind of weird because we have now a vector with 5 elements and one I think this has 15, and we add them together and this works. This is kind of really weird. in Excel, if you would add the values in column A with the values in column B and the columns are not the same length, that should not work, right? Or Excel probably says, oh, where I have no value, it's 0. But this is not what's happening here. Look, it adds the first value, it gets 20.8, that's fine. It adds 5.6 and 5.6 is 11.12. It does this all the way to 21.7 plus 21. Then here it has a 0, but the result is not 0, it's actually 10.4, 5.6, and it has values where all those zeros are. And then it starts with some other values here at the end. And the question is, what's going on? And the answer is, R uses the concept of recycling, which is a very green concept, I guess. It's good to recycle, right? But it can be somewhat confusing. And what they mean by recycling is that when they run out of numbers, so when they add those numbers up, and they run here out of numbers, they start to recycle this vector and start over at the first one. And that's why if you add to 0, this recycled value, which is the next value, is 10.4 again, you get 10.4 again. And you need to understand that this recycling concept is used. And if you make programming mistakes, it might recycle and add stuff up that you didn't want to add up. And then when you want to debug this, you need to say, oh, it probably recycled something because I added up 2 vectors that were not the same length. Let me check those vectors, and you can actually fix it. If you have no idea that there's recycling going on, then it's going to be hard.
So that we just, instead of 5 zeros, we have 4 zeros, you get different results.
There's 1, 2, 3, 4, 5 zeros.
Right. So let's say Y just had 4 zeros, we get a different result here.
So in the good old days in R, you got a really bad bug, and it would like then recycle kind of like offset a little bit, and it would give you numbers that probably don't make any sense whatsoever. Nowadays, R, since I think last December, gives you a warning and says, hey, you're recycling 2 vectors. One is not a multiple of the other. Probably you didn't want to do this, and I warn you. And if you don't want the warning, you have to tell me, no, this is okay, this is really what I want to do. Why do they use recycling? Well, we already saw an example, because we wanted to do, right at the beginning, this thing, x plus 1. And in order to do x plus 1, it actually recycles the 1, 2, 3, 10 times. It's the same concept. It uses the 1 for the first value, then it runs out of values and it recycles 1 and always adds 1. And in order for this to work, it has to use recycling. And that's a powerful concept that makes lots of headache for lots of people, because yeah, when you make an error, don't make an error. That's the answer to that. Errors are not your friends. Okay, so this is recycling, and keep this in mind. Then there's lots of functions that are really helpful. There's a function sum, and I think in Excel it's the same thing, right? You say sum and give it like a column, and it will just sum them up. We have the same thing here. There is a length function that tells you how many elements are in X, and in X are 1, 2, 3, 4, 5, so it will give you this. And there's tons of other functions. Basically, all the ones that you use in Excel, from calculating the variance, calculating the standard deviation, calculating the average, is called mean here, and getting the minimum, getting the maximum, all those functions have pretty much the same name, and you can just call them on this vector. So if you have the columns from Excel, put them in a vector, you can do basically everything that you want to do in Excel, or do in Excel also directly here. Here it's programming. In Excel, they tell you it's not programming, but it's not true. In Excel, you also program when you use functions. This is just a different way to write those things. Sequences. We had a sequence from 1 to 10. We can make a sequence from 1 to 5 here, give it a name S1. And then there's lots of other ways you can create sequences. Doesn't sound so exciting, right? But it's very useful for lots of things. Again, going back to Excel, often you have to fill out a column, and it has to be 1, 2, 3, 4, 5, all the way to 10,000. You don't do this manually, right? You give Excel 1, 2, 3, and then kind of highlight it and drag it down, and it knows that you want a sequence. Same thing here. This knows I want a sequence from 1 to 5. This one knows I want a sequence starting at -1 to 1. And I want it in 0.2 increments. And that's really what I get. So you can construct the same sequences as you could construct in Excel here. And there's some basic things. For example, I could take sequence S1 and repeat it 2 times. So it repeats it once, repeats it twice. I could take sequence S1 and repeat each element 2 times. So it repeats the first element 2 times, the second element 2 times, the next element 2 times, and so forth. And you can find, of course, help for sequence and repeating in the manual pages. And it really replaces.
We use the equal sign for those.
Yeah. Oh, yes. For giving values to function parameters, you use the equal sign. Yeah. But not for the assignment to a name. Okay, so this is kind of takes a little time to get used to, but it's really easy to use, because if I want a sequence from 1 to 10,000 in my Excel sheet, I could just really say S1 gets 1 colon 10,000, and I have the sequence, right? And how we get this into something that looks like an Excel sheet, we will talk about this next time. R uses data types like any programming languages and like Excel as well. Excel, you can have numbers, you can have text, right? And Excel knows that adding up text doesn't really make much sense. Same thing is here. One data type that R can use is logical. And they're just true, false values. And they're literally the text true and false. In R, they decided to make them all uppercase just because they decided so. And you can do comparison like you would do it in Excel. There's a function that's called if in Excel, right? And you can say if something is more than 20, then say, I think it says 1 or 0 or whatever it is. And same thing here. I could look at the vector x. I could look, is it more than 13? These are my values for x. And then I get back as the answer. I save this to name L. 10 is not more than 13. And the only thing that's really more than 13 is the last number, because it's 21. So pretty much the same thing. And if we ask what data type it has, and in R we call this mode, then it says this is logical. It's not a number, it's a true false value. So that's pretty good. If we want this in numbers, then we can do something that's called coercing, other programming language called casting, basically changing the data type. And it has rules how to do this, and the rule that we use is false is 0. And true is 1, and really it just makes it into numbers and converts all falses into zeros and the trues in ones, and then we can do fancy things like sum this up, this vector, and that's the same thing as counting how many trues are in this vector. And in Excel, if you do use it a lot, you probably do those tricks where you like have an if statement, and then you get zeros and ones, and you sum them up or average them, and you get proportions and all kinds of things. So same idea here. There's lots of operators like this, and you can use all of them in Excel, right? Less than, less equals, not equals, forget those are logical operators. And you can find those operators with question mark or just in this help page. You just like put the operator in, and they will give you good examples. Okay. Now something that we don't use a lot in Excel, and most people who learn programming don't use a lot. And those are missing values and infinite values. And that's an interesting thing because it makes life a lot easier for us. Because if we talk about data science, then it's data about like people or objects or something. And sometimes we don't have all the data. Sometimes in a questionnaire, they don't fill out a question. What do we do, right? And they really put in NA. And in R, you can use the special keyword NA for that. You can really say, I have the values 1 through 3. And then the last name value, I don't know. And then literally just write NA. And R has rules that knows what to do if I start adding up things or multiplying things with an A. There's functions to figure out if there's an A here. Function is an A, checks, is this an A, is this an A? It will give you a logical thing. Then you can say the last one is the only one that's an A, and you can work this way with missing values. Did anybody try to divide by 0 in Excel? Or it happened, like not on purpose, but it just happened. Happened to me before, and you get a weird like number sign, something error message. Interestingly, in R, you don't get an error message. It lets you do it, but it actually tells you that the answer is not a number. Because by definition, if you divide by 0, it's not 0, it is not defined, it's not a number. And this is just a special case of a missing value, of a value we don't know what it is. But it's a special one because we know that it happened because we create something that is by definition not a number. If I do anything with a missing value, for example, add 1 to an NA, then there's rules that says if I add 1 to a number that I don't know, then I don't know what the resulting number is, so I give you an NA. And it consistently uses this throughout your calculations. It's really good because if you look at how people use Excel, they say, oh, if I don't know it, I make it 99 or something. and then the average over things, and it's going to be horrible. It's not going to be good. So using missing values is a way more consistent and better way. I think in Excel you would just leave the cell empty, and then it thinks you think it's a missing value, and it just excludes it from averaging and things like that. So this is what this is for. 2 to the power of 5,000 is a very large number. I said it's close to infinity. And since R cannot represent it because your computer can, it actually really encodes it and says this is infinity. And it knows what to do with infinity. If you add now infinity to something else, it's still infinity. It knows what happens if you divide infinity by infinity. What is that? We could test it. I guess it could be also at n in n. It could be 0. It could be still infinity. I don't know what the math rules are, but R knows what the math rules are.
So, sir, if the cell is blank, then are we considered as a...
So if we don't have cells, right? R is not Excel. It doesn't have cells. In Excel, we would leave a blank cell empty if we don't know what the value is, right? Excel. In R, we use NA. We write in the vector, for example, if I don't know what the fourth value is, I just type NA. And it does the same thing as what Excel would do with a blank cell.
Is it equivalent to nullify this in other applications that exist?
So that null is different depending on where you come from. If you come from Java, C++, then null means usually a pointer that doesn't point anywhere. And although if you had even a course in Java and C++ and did not learn that missing values and infinity is really actually a number that exists there, then it's just because you didn't learn it. But in the standards like numerical algebra for computers, any programming language that has the data type double actually has missing values and plus and minus infinity. Just people don't get taught that that's the case, but it does. Null is something different. It's used usually for pointers that don't exist. So we are almost through here. Now just a few more things. We want to deal with text in R as well, and in Excel we can easily do it. We can just type text into a cell, and it's the same thing for us here. We again have vectors, for example, hello and hola, and we can put them here. We have a function paste, which takes two pieces of text and just like pastes them together. And what we do here is we take the string, which is hello and hola, it's a vector, and paste it together with word. And the interesting thing is we get this as the answer. Why is that the case? It says actually hello world and hola world. Not a great example, but that's what it is. Since we only have the word world once in this whole thing, right? We have hello and hola, that makes sense, but there's only one world. Why do we get two worlds? It's because it recycles, right? It has two vectors. One is too short. This has only one value. So in order to put them together, it has to recycle world another time, and it does exactly the same thing that we learned before. A better example is this here. I want to create labels, and the labels should be x1, y2, x3, y3, and I can actually take two vectors and paste them together, and I will get exactly this. It takes the first element here, puts it with the first element here, second element with the second element. Third element here, there's no third element, it starts recycling x, and that's where it has xy, xy, xy. And you can do lots of creative things of creating data by recycling information and creating labels. Okay. So far, so good. Text comes in, those are called, the data type is called character, but it also comes in a second form. And we don't really use it here, but it gets generated by R automatically whenever you use data frames. That's kind of like the equivalent of Excel sheets. And what it does is it takes text and encodes it into a different format. And often it does it when you have, for example, a vector here. This is 1, 2, 3, 4, 5 people, and they are male and female, and we have stored the information for those in this vector. What it realizes is that this is really inefficient. Why do I store like a 4-letter word and a 6-letter word? Why do I store this so much? Although I know it's just repetitions, right? It's always male, female. So what it does, it uses some sort of encoding. It says, what if I make a lookup table with male and female, and then give every person just a number? And this is kind of like how questionnaires work, right? Where you can take a check mark for male and female, and then when they code it, you get some numbers, right? And somebody tells you 1 means, 2 means male, and 1 means female. And R does this automatically, and the reason why I stress this is because then if you do something with those, they are not text elements anymore, but they're actually internal numbers, and really weird things can happen. So if you do something to text, but you get back numbers, then that's probably the problem. It converted them into numbers, and you have to convert it back into text. If you can do this with s.character. So if text does something weird to you, it probably is, this is probably the problem. Okay, let's see how much time we have. We have still a little bit time, so we can talk about subsetting and modifying subsets. So since we have vectors, often what we want to do is we want to look at individual values in our vectors. For example, here we want to look at what is the first value of these vectors. If those are different people, and this is, I don't know, some score that those people got, what score did the first person get? And you can just use the brackets and the index and say, well, the first element of x, give me the answer. It just says it's 10, I guess it should say 10.4. Then what if I want to remove one element here? Kind of equal to, I go into Excel and I want to delete the first, I guess, row. Then you would just use a minus here and just say, please give me everything but the first element. And you see you get now 5.6, 3.1, all the way to 21.7, but the 10.4 is gone here. That's pretty good. You can also do ranges. And that's kind of like similar to how you would write this in Excel, right? Where you say, I want from A1 to A20, you say A1 colon A20. Same thing here, I want from element 2 to element 4. So I want to skip element 1, then 2, 3, 4, and the last one not, and you get this kind of like subset. So it's very simple to cut out different values here. You can also use what we learned about logicals. We can use a logical vector, and we can create it by this comparison, and we can select everything where x is more than 7. And the only ones that we have here is 10 and 22. I have some rounding turned on. That's why 21.7 gets rounded to 22. But that's not the standard one. I just didn't want to have so many decimals on my slides. That's pretty good. But now the really cool thing is you can also select a subset and assign to the selections. So what you basically do is you select cells in Excel and assign values to those cells. And you can do this very efficiently. For example, if I think every value in here that's more than 7 doesn't make any sense. For example, if this is the age of people, and so this person is 10.4 years old, and then there's people who are older than like 200 years, because some smart person said 999 is the age of a person that I don't know the age, because I had no idea I can actually use missing values. Then you could just say, replace everybody who has an age more than 900 years with an A. And here in this case, we replace every number that's more than 7 with an A. What we do is we select this thing, and it's healthy to actually execute this first, see what are the values that are going to get replaced. And if I say an A, then you see it replace the first and the last value, because 10 and 22 are the ones that get selected here. So that is very powerful, and you can do lots of easy data cleaning with that, by just like selecting all the values that are weird and replacing them with NAs. And most people, that's the first thing they're going to do. They're going to go through the data and say, make everything NA where I know that actually it should be not in my data. Okay, subsetting now on steroids. It's really important that when you store your data, you kind of know what is stored in each column and or in each row. How do you do this in Excel? Well, in Excel, hopefully you have data like the first name of a person, second, last name of a person, and then the age, whatever the information is, and you can look what the first name is. You can do something very similar for vectors. You can actually give them names. You can, for example, say my vector is 5, 10, 120, representing I have 5 units of one through 10 units of the other one. And so that I don't forget that in my vectors, the first number is oranges, the second one is bananas, apples, and peaches. I just give it the names. And then whenever I look at my vector fruits, R will actually show me the names. So it's now basically a vector where each element has a name, which is really great, because if you ever worked with like programming or some weird data, sometimes you forget that obviously oranges is the first number. Or if somebody else looks at your data, how are they supposed to know that oranges is the first number? But if they look at the data and they get the names supplied with them, it's way easier for them to not make mistakes, right? And then we can use this even better because now we can actually subset here with those names and can see I'm really interested in taking the fruits, apple and orange, and I can, instead of using an index like before, I can actually use the name. And then it will pick out apples and oranges. And this syntax here, C, and those two strings is just, remember, this is combining two things into a vector, and it just makes a vector of apples and oranges, gives this vector as the indices, and it will pick the correct numbers here. Makes life a lot easier. Whenever you store something in a vector, give the vector names. Otherwise, you will forget, or you will do something. You will, for example, maybe you say, I want to remove oranges, and then you give this data to somebody else, and they say the first number that you give me is oranges, and then they will think 10 is the number of oranges. It's really bad. If you have names here, you will never run into those problems. Okay, we're almost done. Last thing is exercises. And those exercises you're supposed to do at home. Don't be scared. And we will talk about them in the workshop here next week. And it's supposed to help you remember and train all the things that we did here. So the first one is here, for example, create a vector with 10 numbers, and those are the numbers that you should have, and assign them to X. You can just go back to the slides and see how it's done, and do this in R. Please do the recommendations. Make an empty R file first, and then all your code goes in there, so you can actually bring it to class here, to workshop here next time, and do that. Then here, question is, what is the data type?